Hello everyone. This is a lecture for topic transportations problems. So let's get through this chapter. At the end of this chapter, you will learn how to define and explain the transportation problems, and then you able to formulate the transportation problem mathematically. You apply the northwest corner method to find an initial solutions, and then optimize the transportations problem using the stepping stone method. Let's go through this chapter. And then we go to the definition first. So definitions of the transportation model is a type of optimizations problem aiming to minimize the cost of transportation goods from multiple sources to multiple destinations. So the objective of this problem is to determine the most cost-effective distributions plan while meeting demand and supply constraints. So these are the key components of the transportation problems. They will have supply, demand, cost metric, and also the constraints. You need to know what is the supply. So the supply is the total items available at each source. The demand is the total item required at each destinations. Cost metric is the metric showing the transportation cost per unit from each source to each destinations. And then we have constraints so that to ensure total supply equal to total demand, or introduce any dummy row or column if they do not match. So this for our level, we do not touch about the unbalanced dummy row column here. Okay, so our topic cover only for balanced transportations problems. Okay, so now we look into the graphical illustrations. What should you have? The sources, the destinations refer to the demand nodes on the right side. And also we need to have the error representing the possible shipping path labeled with transportation cost per unit. Okay, so these are the steps. So we only focus on this type of method, which is the northwest corner method. So the northwest corner method is this is the step. Okay, the first one is we need to start in the top left corner, allocate as much as possible to the cell at the top left corner. And then you need to move right or down. So if a supply or demand is fulfilled, move down or right to the next cell. And then if the next one is to continue until all supply and demand are met. So we need to stop when all supplies and demand are allocated. So this is a very simple method of the transportation problems. Okay, and then this is about the stepping stone. I will touch this part later on the next video. So first thing first, we need to go through the example one. So this is Supplies is a company that sources product from 3 main warehouses located in different regions to meet the demand of 4 retail stores. So retail stores stand for the destination 1, D1, D2, D3, and D4. And then we have supply at each warehouse, for example, from source O1, O2, and O3. So that is for the supplies coming from. So this is the table. So we need to solve the problem using the northwest corner method. So what is the first step? So the first step is to label what is actually our variable here. So the variable here that we need to figure out is the number of units to be sent to every sources to any of the destinations. So we look into cell by cell. So the first cell here, so let's say this we represent as X11. So 1 for source, 1 for destination 1. And then this is X12, 1 for source O1, and D2 is for the column 2. First row, third row, first row, fourth row. The second row, first column, second row, second column, second row, third column, second row, fourth column. And then third row, first column, third row, second column, third row, third column, third row, fourth columns. So these are the variables that we need to find. Okay, our objective is, so this is the cost. The value inside the matrix here, the cell tableau here is the cost related to the source to destination. For example, cost from source O1 to D1 is 3, and then so on. So that is our cost, so which is per unit. So this is per unit cost. So means that if your units of here is 1, so 3 times 1. So if your answer here is 2, 3 times 2. So we need to find, the objective is to minimize the cost. Minimize the cost of, let's say, the function of z. So which is, we have to list out all of the costs. 3 times x1 1 plus 1 times x1 2 plus 7 x1 3 plus 4 x1 4. And then on the second row, 2x2 1 plus 6 times x2 2 plus 5 times x2 3 plus 9 times x2 4. And then the last row is 8x3 1 plus 3x32 plus 3x33 plus 2x34. So we have the constraint actually. So the same linear programming model, we have the constraint. So constraint, if you look into this table, so basically this is the total units. So means that the sum of this one must not be must equal to 250. The sum of this one must be equal to this one. The sum of this one must be equal to 400. The sum of this one must be equal to 200. Okay, that is by column. If you look by row, this variable summation must be equal to 300. This one must be equal to 400, and then the summations of another row is equal to 500 units. Okay, so if you look here, the summation of demand is 1,200, equal to the summation of supply, which is also 1,200. So we can say that the transportation problem is balanced, means that they should not add any of dummy row or dummy column. Okay, so this is the balance problem. So if you want to list out all of the constraints, so we need to look into row and also into the column. So first, let's say we look into the row first. So the row, x11 plus x12 plus x13 plus x14 equal 300. And then x21 plus x22 plus x23 plus x24 equal to 400. And then the last one is x31 plus x32 plus x33 plus x34 equal to 500. So that is for row constraints. And then for the column constraints, you will have x11 plus x21 plus x31 equal to 250. The second column is, you need to add all of this part. Okay, and then we have third column. And then the last column is equal to 200. And then another constraint is the non-negativity constraint, means that all of the variable must be equal to 0 or more than 0. You cannot be negative value. So all of this variable, let's say it's represent xij, must be greater or equal to 0, with I is our row 1, 2, 3, and then j is 1, 2, 3, 4. Okay, done. Our linear programming model. Okay, so now we need to solve this problem using the northwest corner method. So you need to actually draw a table like this, okay, representing all of the elements there. We need to draw the table first. Okay, so one, two, three, and then we have 4, Okay, so we have O1, O2, O3, and also the demand. And then the destination and the supplies. Okay, so we need to put all of the costs we have here. Just copy paste everything. 6, 5, 9, 8, 3, 3, 2. This is 300, 400, and 500, the supply, and also the demand is this value. Okay, so what is the first step of northwest corner method? Is by filling up the cell at the northwest on the corner left. Because why? If you draw the northwest, north-south, west-east, so this is our place there. So basically, is just representing the end corner here. Okay, so you need to fill up there. How? By looking at the demand and also the supply. So you need to find which is the minimum. So between 250 and 300, 250 is minimum. So we fill up the empty cell here with 250. Means that the demand at the D1 is already satisfied. We already sent all of the demand D1 from the O1 here. So means that O2 no need to send it anymore to D1. O3 also no need to send it anymore to D1. Okay, so means that here is already satisfied the demand at D1 destinations. Okay, so the next step is by moving left or below. Right or below. So it's either right or below. So because below we cannot move anymore, so we move to the right side of this part. Okay, so here also the same. Okay, but I forgot. So because we already satisfied our demand, so the balance is 0. So from O1 source, so they already sent 250. So the original value of supply at O1 is 300. Means that they already delivered 250. So we have balance here. So we need to update our supply here. So the balance is equal to 50. So means that to fill up this one, you need to compare 50 and 350. So how many should O1 deliver? So O1 should deliver about 50 units. Okay, to D2. So means here, if you see, we already use all of our supply from O1. So it means that O1 cannot send to D3 and D4 anymore because we don't have any more supply there. Okay, so we can cancel out this cell. Okay, so the next one is whether to move right or down. So we need to move down. So this is the empty cell. Okay, so since D2 already sent 50, we send 50 units to D2. So they only need balance 300 units here. So we need to update that. Okay, so between 50 and 300 actually. So we choose 50. So, for the next cell here. I'm sorry. So for the next cell here, we need to compare whether 300 or 400. So the minimum is 300. So we'll fill up 300 here. So this one already satisfied. This one we use 300. The balance is 100. Okay, means that the demand at D2 is already satisfied. Okay, so next move to the right cell here. So between 400 and 100, 100 is minimum. So we'll fill up the 100 there. Okay, means that here is already used all of the supply, so we cannot send it anymore. And then down here, we already send 100 units, so we need another 300 units. Okay, so next we move to the below, 300, 500, we choose 300. Okay, so 300, this is equal 0, no more. And then this balance is 200. So the last cell between 200 to 100, so this is 200. So we already use all of the demand and also the supply. So what is our solution? So this northwest corner method doesn't mean it's optimal. So this is we call as initial solutions. We need to confirm whether the initial solution is optimal or not by using another method later on. Okay, but in this case, we need to calculate our cost of Z just now. So because we see here, this is our variable representing each cell. So you just need to time with the cost from each cell. So the first cell, 3 times 250 plus 1 times 50 plus 6 times 300 plus 5 times 100 plus 3 times 300 plus 2 times 200. So the cost would be how much? So we need to calculate that. So bear with me a second. So that is 750 plus 50 plus 1,800 plus 500 plus 900 plus 400. So it's 4400. And then we also have x1 1 equal to 150, x1 2 equal to 50, x2 2 is 300, x2 3 is 100, and then x3 3 is 300, x3 4 is 200 units. Okay, so this is our optimal answer. Other than that, the variable is equal to 0. Okay, so that's end of our part for northwest corner method. So in another video, I will show you how to check whether this is optimal or not by using the stepping stone method. Okay, so thank you. We will see you in the next video.